Let us consider that a parallel combination is there. In AC, sir, how to deal with parallel combination? Little bit tricky, but still it's not impossible. Let me explain this. Let us take a simple circuit of an inductor and resistance parallel connected to AC. In parallel combination, something we already know. Just recall. In parallel combination, what remains same? Tell me. In parallel combination, what remains same?
Voltage remains.
Yeah, voltage remains same. And in parallel combination, do you remember how we add resistances? How we add resistances?
1 by R1 plus 1 by R2.
Yeah, 1 by R1 plus 1 by R2. Right now, it is not required. But remember this. We add 1 by R is equal to 1 by R1 plus 1 by R2. Good. Next part. Next part is that current I coming in, I1 and I2. Current will split here. Voltage remains same. If you go to series combination, observe here. If you go to any series combination, let us take this series combination. In this entire set, observe. Current remains same. Voltage will be divided and voltage is being added according to vector addition, right? I repeat, in series combination, current remains same, voltage will be divided. That is standard statement. Fine. Now, in this case, we took same current and we added voltage like a vector. That's it, right? Same thing, if you understand the logic, you can deal with it here. That is, in parallel combination, voltage remains same, current will be divided, and current must be added according to vector addition. That's it. Now, V, voltage. Voltage is same for both. We don't have voltage across inductor, voltage across resistance. If you want, you can write. But both are same. Clear? Now, current across resistance. Can you tell me current across resistance will be in phase or out of phase with voltage? In resistance, current and voltage will be how? How it will be? Do you remember that? How voltage
So
and
they'll be in phase.
in phase. Yeah, good. They'll be in phase like this. IR I'm writing. Now, what about inductor? In inductor, voltage and current will be in phase or out of phase? Like how much it is? Anyone?
So voltage leads current.
Yeah,
90
voltage leads
degrees.
current, right? 90 degrees. So we can't write current like this. We can write current only like this because voltage always leads. Entire rotation is like this, na? So current across inductor. Angle between them 90 degrees. Now net current will be I. Phase angle is theta over. That's it. Nothing else is required. Next one. What about impedance? Yeah, you can write same impedance phasor. I repeat once again, you should not write impedance phasor in CBSE anyway. Parallel combination is not there in CBSE, no issues. But let us take impedance phasor. In parallel combination, we add impedance or resistance. We add reciprocal of resistance, right? Same thing here. 1 by R, 1 by XL, add them, you will get 1 by Z, angle theta. Clear? That's it. Small point we need to understand. Just a minute. There are totally two paths to deal with. Two different paths to deal with. What way you want to deal is your choice completely. I prefer current method. Okay, I'll explain that what. Just a minute. One minute. Understand this bird's eye view. Two paths are there. Two different paths are there. First path will be like this. You take the circuit. You calculate reactance, resistance, and impedance. Okay. Right. Then you calculate Z value by using what? Impedance phasor. Once you got Z value, you got the total impedance, right? You know voltage. Voltage by impedance is what? Current. From there you can find current like this. Okay. First path. You understand this, you go to the impedance and then deal with it. Second method is also there. What is second method? You take the circuit and then you make current phasor. Okay. Once you have current phasor, add currents and calculate value of I. Once you got the I value and you have already V value, what is V by I or V by I in this case is Z. You calculate Z like this. Okay. Whatever way you want, you can go through. I always go through current phasor. I always go through current phasor. Nothing. I won't go through any other method. It's my choice. I'll always calculate current. I add current. I'll get net current. Then net current, once you got it, then you can find impedance Z. Okay. The other way around also you can do. That's what the final thing. Let us take an example problem. This is the problem I'm taking an example. Good. How to deal with this? Observe V value. Whatever you use 12 for V, right? 12 is maximum value, not RMS value. No problem. We'll get all the information on entire data in maximum values only we get. What's there in it? Let us continue. That is, see, first of all, current I is coming in. IL, IR. That's it, right? We need to write the current. I told you, I prefer current phasor. I don't go through impedance and all. Okay. Let us take it like this. Voltage is like this. Then current across resistance will be IR. And then voltage across current across inductor will be IL. 90 degrees. I angle theta. Okay, good. Now what to do? We'll calculate XL. XL is equal to omega L. That is equal to omega is 100. L is 30 millihenry. 30 into 10 power minus 3. So it is how much? Tell me. 3 ohm. Right or wrong? XL. Then IL. IL is equal to V by R. What is voltage across this one? 12 only, right? By R. What is R value? 3. How much? 4 times, right? 4 ampere. IR is equal to 4 ampere I'm taking. Next part. R we know. R is equal to 4 ohm. IR is equal to 12 by 4 is equal to 3 ampere. Okay. IL is equal to 3 ampere. After this, simple phasor addition. Can you tell me what is I value?
5.
Five.
5.
What is the theta value?
37.
53 degrees.
53.
53.
53. Okay. Now, if you want total resistance or Z, okay, total volt Z is equal to total voltage by total current. How much? 2.4 ohm. That's this. You can go through impedance also, but I don't do that. I don't do it. Clear? That's it. Now you have to practice. 1 or 2 questions we can do. We have 5 ohm resistance and 5 millihenry connected in parallel. First, I'll write the phasor. I'll see how it is. My idea is only with current phasor. Okay. So, good. I have voltage V and that is equal to 10 is given. And then IR will be there. IR will be always in phase. And IL will be 90 degrees lagging. And the circuit will be like this, current I, phase angle theta. This is what we need to find. I'll go through only current method. Okay, right, we'll start. That is, first of all, I'll calculate IR. IR is equal to V by R, 10 by 5, 2 ampere. Okay. IL, I need omega L, right? I need XL or else. We call it as XL. XL is equal to omega L. Omega is 10 power 3. L is equal to 5 into 10 power minus 3 millihenry, na? That's why. These two gets cancelled, 5 ohm. Okay. Omega L is equal to 5. Again 10 by 5, 2 ampere. Good. 2 ampere, 2 ampere. At an angle of 90 degrees. So according to vector addition, simply I can write I is equal to 2 root 2, right? Direct step I'm writing. 2 root 2 ampere. And theta is equal to 45 degrees. Nothing. Easy. Very easy. Okay. Okay, fine. Now, how do we deal with? I recommend not to, or I don't do that way. I don't do that way. But anyway, let us just briefly explain how to deal with phasor impedance phasor. We take resistance and resistance 1 by R, 1 by R and 1 by XL. Then the resultant will be like this. 1 minute. 1 by Z. 1 by Z. This angle is theta. So I calculate the value. What is 1 by R? 1 by R is equal to 5 ohms, right? And this will be 1 by 5. 1 by Z will be squaring and adding root 2 by 5. Correct? Good. I got Z value. Z is equal to 5 by root 2 ohm. Good. Now I want current. Current is equal to voltage. Voltage is 10 by 10 by Z. Z is equal to 5 by root 2. Now root 2 go to numerator and 5 2 times. What the value? 2 root 2 ampere. Check it exactly same. Whatever way you want, you can deal with it. Whatever way you want, you can deal with it. This method is also okay, but I don't follow. It's my choice. Of course, theta also you can find because you know z value or you know this value and this value, and theta is equal to what will be 45. Directly, you will get the answer in the this one also. So there is another line of solving. You can do that way, but no, I'll follow only current way. This is my points. Clear? Good. Question number 2, diagram is given 25 microfarad, 4 ohm, and this is the value, right? Good. Now observe. We'll write the phasor first. Voltage, 2 volt is given. Current IR will be like this. But think about IC, how it will be. IC will be, can you anyone tell? IC will be down like this or up or parallel?
Up.
Up. Why? Because in case of capacitor, current will lead, na? That's the case. So IC will be up and 90 degrees will be there. Resultant will be I and angle is theta over. I'll calculate. I'll calculate XC is equal to 1 by omega C. 1 by omega. What is omega? 20 into 10 power 3 into C. What is C? 25 into 10 power minus 6. Suppose if I take this one 10 power 3 and minus 6, it will be 10 power minus 3. This 10 power minus 3 will go to numerator, it becomes 10 power 3 by 20 into 25, 50 or 500. So I can say like this will be 1000 by 500, 2 ohm, correct? Okay. Now I calculate current. IR is equal to V by R, 0.5 ampere. IC is equal to V by XC. V is how much? 2 by 2, 1 ampere. Now we got the data. IC is equal to 1. IR is equal to 0.5 or 1 by 2. Then I will be equal to squaring and adding. So 1 square is 1. 1 by 2 square is 1 by 4 under root. This is the current, right? That is equal to root 5 by 2 ampere. So total current I is equal to root 5 by 2 ampere. Some students may feel, sir, because they asked current, you did like this. If they ask impedance Z, then you have to make impedance phasor. No, not required. If they ask Z, what to do? Very simple. You have the total current, total voltage. Z is equal to V by R. You can do like this also. That is equal to 4 by root 5 is Z. So for Z, you don't need to make that phasor. The path you see, you will understand. My path is like this. Take the circuit and go make the current phasor and calculate current. From there also you can find Z. No issues. We slightly one step lengthy, but I'll strictly follow this method. Okay. What next they want? There is one more question in that. Calculate angle. Directly you can't calculate. You can say tan theta is equal to 1 by 1 by 2 because it's 0.5, na? Opposite side by adjacent side. Repeat. Opposite by adjacent, tan theta. So 1 by 2, that is equal to, that implies theta is equal to tan inverse of 2. That's it. First, let us calculate XL, XC, everything. XL is equal to omega L is 2 kilohertz. L is equal to 20 millihenry. The omega L value is 40 ohm. XL value is ohm. XC value. XC is equal to 1 by omega C, that is equal to 1 by omega. Omega is equal to 2 into 10 power 3 into C. C is 50 microfarad. 50 into 10 power minus 6. 10 power 3, 10 power minus 6 will be cancelled, and then numerator 10 power plus 3 will come. 2 into 50, 100. 1000 by 100. 1000 by 100 is 10 ohm, right? 10 ohm. Resistance is already there. This one. Now you need to understand this part. First part is these two are series. Whatever we got it, that is in parallel with 20. This is the key logic. Okay? Right. So, same standard stuff we do. Current I is coming in. IL. I don't write IC because IC if I write, it gives a misconcept or maybe kind of wrong information to me that it is only capacitor. No. So I'll write I1. That's what I do. You can write IC also. Now first you combine them in series. Series combination, you know how to deal with it. Then add them with parallel. That's the logic. Okay. Try. First of all, this inductor is not having any problem because simple inductor, straightforward, no issues. But here is a problem. So there is a circuit here. There is a circuit here. And this is in series. So I'll calculate series first. Series I'll calculate. How do I calculate in series? In case of series, voltage across 1 minute. Voltage across resistance will be VR and capacitor. Capacitor means voltage will be like this, right? Lagging. And current will be like this. Yep. Obviously current, right? 1 minute. Yeah. Current will be like this. And the voltage will be like this. This angle is theta. This angle is theta. Remember, this is not the final angle. Final angle is totally different. And this is not total current. Current will be I1. This is I1. And this is voltage across the source, which is equal to 20. Because net voltage across this is net voltage across. There's no problem at all. And this is voltage across inductor. Sorry, voltage across resistance. Voltage across capacitor. As you know very well, in case of series combination, we make impedance phasor and deal with it, right? Z, R, XC. Values are there. Values are there. R is equal to 10 root 3. XC value is also there. XC 40. XL 40. X is 10, right? Sorry. 10. Now Z value. Obvious, no? Z value. No, it's not Z, Z1. Because Z is total value. This is Z1 I'm taking. Z1 is equal to 20. And this angle is 30 degrees. So this is 30 degrees. Clear? Any problem here up to this? What is my statement is, if you want to take them together as a single system, if you take only this one, then you have to take current and VC. If you want to take only this system, you should take these two. If you want to take entire thing as single combined system, then you should take this part. Sir, how? I'll make the diagram 1 minute. This is the case. Over combined, na? These two are combined and we got this phasor, right? Okay. Let us go for inductor. Let us make inductor also. Inductor current will be IL and voltage will be, oh, inductor voltage is like this, right? Voltage will be VL okay. And you know very well, in case of inductor, voltage will lead what? Voltage will lead
Correct.
current, obviously. Voltage will lead current. Up to this is correct. Now, check it. The key logic here. If I add them in series, focus here. If I want to add these two, in series, how do I add? In series, what remains same? Current remains same. Okay. So what I'll do is that I'll take this and I'll take this also. I'll superimpose in such a way that current will sync. Are you getting my point? That's how we wrote all the series combination, whatever we did. Check it. No, everything, whatever we did. If you take voltage across inductor and current, this is the the diagram for inductor. This is for resistance. We superimposed by synchronizing current because in series current is same. In parallel, we don't synchronize like that, right? In parallel, tell me what should be same?
Voltage.
Voltage should be same. So what my point is that this upper part is, let us take as element 1, this one, upper part. Lower part is this part, this one. Fine. Now we have to superimpose them such a way that what remains same? Voltage remains same. So to make it like that, I'll take this one. I'll rotate in such a way that voltage comes like this. And I'll take the other one also. I'll rotate in such a way that voltage also will be there. Yeah, bad luck in this case, voltage magnitude is not same. Voltage magnitude is not same. So let us adjust things. Let us, 1 minute, let us adjust the things. This is VL I'm writing. In reality, VL or V, everything is same, na? Because parallel combination of voltage remains same. VL, just a minute. And for the sake of synchronization, I'll adjust the voltage phasor like this, right? And this voltage is what? 20. For time being, this angle 30, I'll take it out. Right. Now observe. Superimpose. No, I can bring 30 also, no problem. It won't disturb, yeah? Over. VL or V or V, that's V. V is equal to how much? V is equal to 20, sorry. Yeah, 21, 20. I1. I1 we can calculate. IL also we can calculate, right? Good. IL. First, let me calculate I1. Total resistance is Z or impedance is Z. Z is equal to 20. 20 and 20, right? What is I1? Anyone can help me out? 1 ampere, right?
1 ampere.
I1 and both, because this upper part of circuit has voltage 20 and impedance 20. 1 ampere. I1 equal to 1 ampere. Done. What is IL? IL is easy to calculate. IL is equal to V by what? XL. 40. What is the value? 1 by 2. Now IL is equal to 1 by 2 ampere. Just for sake of, rough, I want to see that everything is perfectly synchronized. Synchronized like rough estimation. So what I did is that I increase the size of it, size of this one, because 1 ampere, this is 0.5 ampere. No? So it's like, now what to do? Resolve this into parallel perpendicular. I repeat, resolve this into parallel perpendicular. Then the entire circuit turns out to be, after resolving, there are two parts. One part is like this and another part is like this, right? Okay. Sorry. What is parallel part? Parallel part is, tell me what is the parallel part? I cos 30, I root 3 by 2. What the value?
Root 3 by 2.
I sin 30, what the value?
0.5.
I into 1 by 2. So this is 1 by 2. Now you see this 1 by 2, this 1 by 2 gets cancelled, right? So these two gets cancelled and voltage is this one. The total current I in the circuit is root 3 by 2 ampere. Total impedance is 20 by root 3 by 2 is equal to 40 by root 3 ampere. That's it. Nothing else. Nothing else. That's it. 40 by root 3. That's it. What they want? 40 by root 3 and current is 1 ampere. 1 ampere in the upper loop and root 3 by 2. And what the phase angle? 0. That means actually the circuit is at resonance. The circuit is at resonance. Regarding resonance, I sent a video. For series, you just go through it. This is the case. How I'm dealing with it. First of all, you know how to handle series. Just simply handle series and get the resultant current and resultant voltage. Now take the other one. Maybe there also you may have series. No problem. Then combine them. Now, after that, you need to synchronize for what? Voltage same. That's it. Over. Observe. We calculate XL, XC, everything. First we do that and then we'll see. XL is equal to omega L. That is equal to omega is 10 kilohertz, 10 into 10 power 3. L is 3 root 3 by 2. So I can say like this. 2 how many times? 5 times. 5, there is a 15 root 3 for millihenry. Na? I missed milli into 10 power minus 3. These two gets cancelled. It will be XL is equal to 15 root 3. Okay. 15 root 3 ohm. Fine. XC. XC is equal to 1 by omega c. What is omega? 10 kilohertz. 10 into 10 power 3. C is 10 microfarad. 10 into 10 power minus 6. Correct. 1 by, correct? Then these two gets cancelled and numerator 10 power 6 will come, or 1000. 1000 means these two gets cancelled. 10 ohm. Okay. Xc is equal to 10 ohm. This must be right. That's what I told you. No? From the beginning, I'm telling you. I don't know what is the question. I don't care. I'll calculate XL, XC first always. Most of the times it will be useful. Maybe 1 or 2 cases, special cases where you don't need it. That's it. Otherwise, it will be always required. Always it is. No doubt. I don't have any doubt on it. Okay? Right. So, we'll continue after this. First of all, I'm taking upper circuit. In that current, I'll take it as I1. In this, I'll take current as I2. The total current is I. Good. First of all, upper circuit I'll take. In upper circuit, check it. I need to take the voltage phasor. This voltage across inductor and voltage across resistance and current result. 1 minute. The total voltage will be like this. Standard stuff. I think we know all these things. We did a lot of problems. That's it. This angle is theta. This angle is theta. Okay. What is this VL and all these things we need to? How do we find all these things? You know very well. We make impedance phasor. By using it, we will find. That is first thing. R is equal to 15 ohm here. And omega L is 15 root 3. Then this will be theta. Theta is tan theta is equal to root 3 means theta is equal to 60 degrees, right? Theta is equal to 60 degrees. That's great. Then 30 ohm, right? Correct, 30 ohm. That's good. Then what is the total voltage? This is 12 volt. This 60 degrees means what? This is 6 volt. And it will be 6 root 3 volt. But anyway, we don't need these voltages actually. And I need current I1. I1 is equal to V by R. I1 is equal to V by R. What is V? 12 by R. R is equal to 30 ohm. Oh. Two by 5 ampere. Right? 6 twos are 6 fives are. Okay, I'll leave it as 4 by 10 ampere. Okay, I1. And remember, from this, what we need is only this part. Remember, theta is given. Theta is equal to 60 degrees. Ultimately, we need only this part. So this entire circuit, upper part of circuit, sorry. Entire this upper part of circuit is acting like a device where current and voltage are out of phase by 60 degrees and current lags behind by 60 degrees and the value is 4 by 10 ampere. This entire thing completely behaves like this, right? Good. Next part. Second part also we have to do. Same logic. Second part I'm trying. 1 minute. Space is not there. Let us continue. Voltage across resistance. Voltage across capacitor. Current. And resultant voltage in the second case. So this is 12 volt and this is VR, we don't know. This is VC, and remember 2 different VRs are there. Inga VR where, inga VR where, but I'm taking them separately, na? So no need to worry about that. So the circuit is like this, and there is a phase angle theta. And remember previous question theta, this question theta, this is totally different. So let us call theta 1 previous one. Now theta 2, good. Now what next we do? Simple, we make the phasor. In series combination, we blindly make the phasor and continue, right? Phasor we want to make. Then VR, R is equal to 10 root 3 ohm and XC is equal to 10. Then it's obvious theta is equal to 30 degrees and this will be 20 ohm. Right. Then current will be equal to 12 by 20. What is the value of current? 12 by 20. I2. 12 by 20. 6 by 10 I'll take. I2 equal to 6 by 10 ampere. That's it. That's enough for me. I don't need to find voltages here because I don't need any voltage across any device. So actually time waste. This entire thing can be considered as a device like this, whose current is leading by voltage like this. Now observe carefully. What I do, I take upper circuit, entire circuit phasor, lower circuit phasor I'll take. I'll superimpose them. So I'm copying it. And this one also. Now what we need to do is that for time being, these numbers are disturbing. So we'll keep it aside for this. And for this also, we'll keep it aside. Oh, wait, theta 2 is what? 30 degrees, right?
Yes, sir.
Yeah, theta 2 is 30 degrees. Okay. It's disturbing. So what we do is we keep theta 2 also outside. Is equal to 30 degrees. Theta 1 also will keep it outside. 12 volt I'll keep. Okay. Circuit 1, everything on the left hand side, circuit 2, everything on the right hand side. Now, what to do, tell me. We have to superimpose these two such a way that voltage remains same. They have same voltage, na? What combinations? Series parallel combination. So we rotate like this and we rotate like this so that they synchronize. Exactly like this. Super. My bad luck actually. The diagram doesn't came in phase. Okay, fine. Actually, this should be 90 degrees because one is 60, one is 30, na? Isn't it? So this is, of course, both are 12 volts only. Both are 12 volts only. This one. Theta 1 is 60 degrees. Theta 1 is 60 degrees. And current is 4 by. This is first one. Second one. Theta 2 is 30 degrees. I2 is this one. Bada. We got the final combination of phase. The resultant will be how much and all these things you need to calculate. It's purely mathematical. How much you do. That's the case, right? Now, resultant current is easy to calculate. Vector addition, na? 36 plus 16 by 100 under root. How much it is? 52, right?
52.
Root 52 by 10, total current. What is the question number? Question number 13. I accept that I took wrong data. It's not 2, it's 4. Accept it. But if it is 2, whatever I did is absolutely right, no doubt. This is the current. Anyway, after that angle you want to find, a little bit complex it is. Yeah. If no, sir, I want angle, then how do we do is that we resolve it parallel perpendicular. Okay. So parallel part of current will be 6 by 10 cos 30. What is cos 30? Root 3 by 2, right? 6 by 10 cos 30 is root 3 by 2. 6 by 10 into cos 30 is root 3 by 2. We'll keep it as it is. 3 root 3 by 10. By 10 will maintain. And then we go for the perpendicular component. 6 by 10 sin 30 is 3 by 10, right? So 3 by 10. Next thing, we take this also, we resolve. Once we resolve, then this will be 1 minute. 4 by 10, 4 by 10 sin 60. What is sin 60? Root 3 by 2. Right or wrong? Root 3 by 2. So it will be 2 root 3 by 10. 2 root 3 by 10. And then there will be one more parallel component, right? Like this. That will be 4 by 10 cos 60. Cos 60 is 1 by 2. 10 by 2 by 10, right? Right. 2 by 10. Now total value will be, total x value will be, I'm going to write the diagram once again. Total x value will be 2 root 3 plus 2 by 10. And 2 root 3 value is more than 3, na? So net will be downwards then. Then I can say 2 root 3 minus 3 by 10. And resultant will be like this. So if you want angle, the resultant is a little bit difficult to calculate. I think you can understand from this. Right. The angle theta, if they want, tan theta, opposite side by adjacent side. So 2 root 3 minus 2 by 2 root 3 plus 2. This is the value tan theta. I took wrong data. But still, this is logically, this is correct. Whatever it is correct. Learn from this. That's all for today. Thank you.